Hi guys, this is Miss V. I caught a call from my son's daycare yesterday saying that he had had diarrhea too many times, so he has to stay home from school today, which means that I have to stay home from school today, but yes, you still have to learn. So here's our agenda for today. We're going to take a few minutes to review the electron configurations that we talked about yesterday. I'll explain what happens when we move into the D block. It's really simple. And then for the rest of class, you guys will be completing the practice pages, the practice problems on page 1 if you didn't finish them yesterday, and the practice problems on page 3 for today. So if you have not gotten out your white note packets from yesterday, get out your white note packets and go to pages 3 and 4 of your notes. On page 4 of your notes, at the very top of the page, it says, recall that electrons are arranged in energy levels in three-dimensional space. We label our energy levels N, so N equals 1, 2, 3, 4, 5, 6, 7, 8, etc. We see those energy levels on the periodic table. So the first energy level is the first row, that's hydrogen and helium. The second energy level is the second period on the periodic table. The third energy level is the third period on the periodic table, the fourth, the fifth, the sixth, and the seventh. In each energy level, there are different sublevels. Yesterday we talked about 4 different sublevels. We talked about the S sublevel, the P sublevel, and the D sublevel. We also talked about the F sublevel, but we won't be talking about that level anymore for this unit. Just know that the F sublevel exists. We don't deal with it. Each sublevel is made up of different atomic orbitals. So if you remember from yesterday, the S sublevel has 1 atomic orbital, and each atomic orbital can hold up to 2 electrons. So if the S sublevel has 1 atomic orbital, that means at the maximum, each S sublevel can hold 2 electrons. Your P sublevels, remember those are the little dumbbell-shaped orbitals? You can have a total of 3 P sublevels in each energy level. If each atomic orbital holds 2 electrons, you can have a total of 6 electrons in the P orbitals. The S is a little sphere. The D orbitals were the clover shapes. You can have up to, well, not up to, you will have 5 atomic orbitals in your D sublevel. Each atomic orbital holds up to 2 electrons. That means that the D sublevel can hold a total of 10 electrons. And again, we see this on the periodic table. So the S sublevel is those first 2 groups, your alkali metals and your alkaline earth metals. Your S sublevel can hold 2 electrons, and that makes sense when we look at the periodic table. We have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Your P sublevels are located here on the right side of the periodic table. And again, it makes sense when we look at the periodic table. Your second energy level has 1, 2, 3, 4, 5, 6 electrons. Your third energy level has 1, 2, 3, 4, 5, 6 electrons. Your fourth, 1, 2, 3, 4, 5, 6. And the D sublevel are your transition metals. Your D sublevel for each energy level can hold up to 10 electrons. So for this energy level, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That makes sense. So if you look at your first energy level, you should hopefully notice that there is only an S orbital in the first energy level. You have 1s1 and 1s2. For the second energy level, you have an S sublevel and you have a P sublevel. For the third energy level, you have an S sublevel, you have a P sublevel, and you also have a D sublevel. And I know what you're thinking, but miss, there's no D block right here. There is a D sublevel for the third energy group, It's just that the d orbitals are kind of funny. The d orbitals are funny because they drop down in energy level as you move across the periodic table. What I mean by that is there's energy level 1, energy level 2, energy level 3, and energy level 4. As you move across the periodic table, this is still energy level 2. This is still energy level 3. For your fourth energy level, you have 4s. And when you move into the D block drops down in energy level. So you would go 3s2, 3p6, 4s2, 3d10, because there are 10 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you would come back into the fourth energy level as you move across the p block. That is true for each energy level. So at the fifth energy level, you would go 5s2, 4d10, 5p6. That's true for the sixth energy level. 6s2, 4d, 6p. So I'll do 3 examples for you of how you determine the electron configuration, including elements that fall in the D block. So I'll do vanadium. Vanadium is atomic number 23. It's located right here. To do the electron configuration for vanadium, we always start the same way. This is where I'm trying to go. I always start with hydrogen. All elements fill their orbitals the same way. The first orbital is a 1s orbital. It holds 2 electrons. The second orbital is a 2s orbital. It holds 2 electrons. The next orbital is a 2p orbital. It holds 6 electrons. 3s2, 3p6, 4s2. But remember, when you move into the D block is funny because they drop down in energy level. So we would go 3D, 1, 2, 3. 3D, 3. That is the electron configuration for vanadium. Our next example, is iron. Iron is Fe, it's atomic number 26. So I'm trying to get, right here, we always start the same way. You always start at hydrogen. The first orbital for every element is 1s2, then 2s2. We have to go all the way across the second energy level, so 2p6. Now that I have filled my second energy level, I can move to my third, 3s2, fill my third completely, 3p6, 4s2, and then I go into my D block. Remember that the energy level in the D block is 1 less than the row that you're in. So this is the third energy level, D block, 1, 2, 3, 4, 5, 6. 3D, 6. You still always write 4s2. The 4s energy level is filled first, and then you can start filling the third D orbital. Our last example is nickel. It's going to be very similar. Nickel is atomic number 28 on our periodic table. This is where I'm trying to go, but we always start at hydrogen. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then our D block drops down in energy level, so this is 3D, 1, 2, 3, 4, 5, 6, 7, 8. 3D, 8. I'll do one more example. If I wanted to go to gallium, for example, My electron configuration would be very similar. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. I would fill my D block completely, 3d10. Then I would be back at the fourth energy level. This would be 4p1. So notice that I just went straight across the periodic table. 4s, 3d, 4p. Or you would go 5s, 4d, 5p. Or 6s, 5d, 6p. Okay? Those are 3 examples. The rest of them should be pretty straightforward. You have practice to do on pages 1 and 3. I expect this to be finished when I come back on Wednesday. Have a great rest of your day. You guys be good for the sub. Hi guys, this is Ms. V.